I recall we had a some very passionate remarks being raised in the morning regarding the use and conservation and consumption of timber. And I suspect the same level of passionate interaction, because I'm also going to I'm going to make a case for timber as the material for the 21st century. So this is my topic. Uh, so this is my topic, and I'm going to make a case for timber as the material for the 21st century. And probably some of you might be feeling a bit sleepy, so I guess how many of you might have looked up in the evening sky on a clear winter night? So if you have done that, you might recognize what this image is, right? So this is the Milky Way, right, our galaxy. And the reason why I show it is, if you are making any guesses, there are about 400 billion stars in our Milky Way. Right? Just keep that number in your mind. And there are 3 trillion trees on Earth. Right? So it's almost about 1,000 times more trees on our Earth than we have stars in our Milky Way. And of those 3 trillion trees, as per the recent official document released by the Ministry of Forest, Agriculture and Forest, of that 0.8 billion trees are in Bhutan. Right? But then we need to qualify what do we mean by tree. Right? So I think the technical definition that they use to define tree is any tree, if you measure the diameter of the tree at a breast height level, and if the tree diameter is about more than 4 to 5 inches, then you qualify that as a tree. So any shrubs are not considered as tree. So this just to set the tone for my talk. Right? So we have more trees on Earth than we have stars in our Milky Way. Now, why tree, right? So people might be wondering why we talk about timber, and then we talk about the population, right? So by 2050, our world population is going to touch 10 billion people, 3 billion people more than what we have right now, and each one of those individuals will need a shelter. So by some estimates, by 2050, 100,000 homes needs to be built a day. Right? So then what are we going to use to make those homes? So we already are being told about the need to limit our global temperature rise within 1.5 to 2 degrees centigrade. Right? And what are the main causes of those global warming and climate change? So the building industry is a big player in the overall, one of the biggest reasons why we're not able to really take control of our carbon dioxide emission. So what is the ecological footprint of a building industry? So just to show it briefly, it is responsible for almost 40% of all these different categories, right? 40% of global resource consumption, 40% of global energy consumption, 40% of greenhouse gas emission, and 40% of solid waste generation comes from the building sector alone. And why is this? Because of the use of the conventional construction material of of steel and concrete and other plastic materials. So it's a choice we have to make now, right? Do we save the planet and forget providing shelter, or do we provide shelter and then at the risk of putting our own future in danger, right? So it's more like a Sophie's choice, right? Either way, you are damned. So then what is the solution here, right? So the solution is, luckily or fortunately, timber does offer a solution here, right? So I'm going to make the case as to how timber is going to make a solution here. So why timber, we might wonder. So I'll put that under 4 categories. Right? So being an engineer, and of course, safety of the occupants of a building or a bridge is of utmost importance. So I have to make the structural case for timber, right? Why is it better than steel and concrete? Worried about the energy use, I have to also make a case for energy consumption. We have to also make the case for the environment. And of course, cost, right? Ultimately, everything is about cost. So how much is it going to cost us? So I'll make 4 cases, just run through them briefly. So just ignore everything that's on the slide. Just focus on the numbers here, because there are too many. So just focus on the numbers. So the bigger the number, it's better, right? So keep it at that right now. So if you see a bigger number, then it's better. So at first glance, it might seem that timber, okay, if you take spruce, for example, is the least favorable of the 3, right, the conventional materials, because it has got the least number here. But that is for the general public, right? But for an engineer, and especially a structural engineer who is involved in designing bridges and buildings, this is not very important. The second segment of the numbers are very important to us. So when you go there, right, and it's a different scenario altogether. Wood almost as equal as steel, but as you go further right, the two conventional material cannot compete with wood in terms of efficiency. The only comparable material that we have at the moment are carbon composites, right? But these are very high energy intensive artificial material that is produced by the industry. And you can see they have some comparable values as comparable to that offered by timber. So from here, what we get is there's a high premium on being light, right? So what is the secret to that? Because wood is light, right? It will float on water, right? So the density is 0.5, so it's half as heavy as water. So there's a high premium on being light. The second case, the energy case, right? So forget all the other material, just focus on the composites, right? Which has almost the same level of efficiency as wood. But then what would be the amount of energy you would need to invest to make a segment, say a building of carbon composites? You can see so if you need 1 unit of energy to make something out of steel, you only need about 2% of the energy to make something out of wood. You would need 17 times more energy input to make that segment out of carbon composite. So that's the energy case for wood. So what pays off eventually is not carbon fibers, it is holes. Right? Because holes are very cheap, and then they do not need money, or like, who needs money to pay for empty space, right? So it's quite cheap. So thus nature invented wood. Right? So holes it is, right? So if you look at a timber properly, it's almost everything is holes inside, right? So this is a Douglas fir, right? You dive in deeper to look at it much more closely, then you begin to see all the holes that makes up the internal structure of a wood, right? So it's holes everywhere, right? Cavities through which waters and nutrients flow up and down. So all of you might know this very famous person, right? Muhammad Ali. So a famous phrase was assigned to him, right? He's popularly known as the person who flies like a butterfly and stings like a bee. So I call timber the Muhammad Ali of construction materials. Right? So it's very light but very efficient, right? Very effective. Right? So if anything you can take out from this conference, maybe if you remember this, I think I've done my job, almost halfway done my job. So moving on. So the environmental case, right? So this is the crux of the whole debate or discussion we're having, right? So you go to concrete steel. So steel, some might say is 5%, some might say 3%, but I've taken the much conservative value of 3%. So 3% steel is responsible for 3% of carbon dioxide greenhouse gas emission in the world. Concrete about 5 to 8%. What does wood do? Right? A cubic meter of wood, say a chunk of furniture in your house, would capture in almost a ton of carbon dioxide. So it locks in carbon dioxide, it sequesters carbon dioxide, it will not let it go out. Rather, in the process, a cubic meter of wood would release about 550 kg of oxygen. Right? So that's how we survive. And just to put that in perspective, so if you fly, for example, right, frequent flyers might be quite conscious about the environmental impact of their habit. So it's about 1.6%. Airlines, shipping, all these logistics, widely used building material is about 5%. It's responsible for 5% of the carbon dioxide emission globally. So that's the environmental case for timber. There are some other data, but because in the interest of time, I might skip that. The sustainability case, right? So some species, I think they're very fast-growing species, so people from the forest might be able to give more information. So timber can take just about anything between 20 to 25 years to grow from a sapling stage to a full-grown mature timber. Right? So it has been found out that enough wood for the 7-story building is grown every 15 minutes in the US and Canadian forest. Right? And think of the replenishment cycle of the raw materials needed for steel and concrete, right? Limestone and iron they recycle under geological timeline. Right? It takes thousands of years for the raw materials to recycle. And finally, the money case, right? The economical case. So researchers all around the world have found out that some of the research it's not really all around the world, but some researchers conducted in Australia, in Canada, in Europe found out that it's 20% cheaper, 30% quicker, 4 times lighter. So lighter the material is, there's an ease of handling and erecting your structure much faster, and better safety outcomes. And then you also get a bonus, right? All of this packaged in the natural warmth and comfort from a wood, right? So an architect once said he has never seen his client go and hug a column made of concrete and steel, but I've seen people hugging and feeling the timber panels or woods in the building that he has designed, right? So you get that feel of and that warmth and comfort if you have buildings made out of timber. So just to show you some pictures of where the wood technology how the wood technology has evolved. So this is the epitome of, right, the epitome of timber technology, right? More than 1700 years old, still standing, withstood all hurricanes and earthquakes, made out of timber in Japan, the pagodas in Japan. This is a timber building recently finished, constructed in Norway, 80 meters tall. And what's the future? This is called the Oakwood Tower in London. It's going to be about 80 stories, 340 meters tall, purely made out of timber. Right? So this is the past, the present, and the future of timber. So what's happening here in our country? Right? So it's not that we are alien to this timber, the technologies and practices linked to timber. Right? We have a pool of knowledge accumulated over ages of our association with timber. Right? So there's a very simple timber bridge, a balsam bridge built in Punakha, bamboo timber composites. Right? So very elegant, very beautiful structures. But what's happening at the moment is with this overdrive or the advent of the so-called modern construction materials of timber, of steel and concrete, people are using these materials much. There's a decline in the use of this material, and the danger is in the long run we might even lose the technical know-how and indigenous practices that we are used to. But saying that doesn't mean that there's no problem with timber. Right? Timber does have its own weaknesses. Right? So what are the challenges? Right? So, but then I'm of the opinion that if you do nothing because of the challenges, then it might be a case of missing the forest for the trees. Right? So just for saving a tree, you're losing the larger picture then. Right? So, but there are challenges, but then there are ways to also overcome these challenges. Right? So the first challenge, of course, so every time I talk about timber, be it my students or anybody I know, they say, you're going to cut down all the trees. Right? So we need to save the forest. There's a mandate to protect, keep at least 60% of coverage on the forest. So are you going to advocate cutting down all the trees? Right? So it's important that we don't miss the forest for the trees, and a right balance has to be struck between consumption and conservation. Right? So how do you do that now, right? So that's where the ecologists or the conservationists should come in, right? So the idea that's going around in the world right now is just as we grow our food, there is a potential to grow our homes, right? So because timber we can harvest them within a cycle of 20-year period. So can we not also think of growing our homes? Right? So maybe it might take too much time, but so how do you do that then, right? So there's a very groundbreaking research done by this ecologist, Professor Susan Simrad. So what she discovered was the trees actually communicate, right? So in a forest wooded area, the trees in fact really communicate with each other. So she called this wood wide web, right? So just as we had World Wide Web, so she called this the natural internet, nature's internet. So the key point here that we can take is, so there are some important trees in a forest, right? So if we make sure that we don't chop down those trees, what she called as the hub tree or the mother tree, because they are key to the survival or the how well a forest ecosystem thrives, right? So long as we can identify those mother trees, we can cut down trees, but then make sure that the mother trees are protected. Right? So that's nature, she called it wood wide web. So what lesson can we learn from there, right? So just as I said, so conserve the herb tree, right? Just to skip through the slides in the interest of time. Fire is another problem, right? So everybody thinks of timber as being very vulnerable to fire, but it is not the case that steel and concrete are any better, right? In fact, the reason why the Twin Tower collapsed is not because of the impact of the aeroplane, but it's because of the ensuing fire that has melted the steel, right? So in fact, steel is much, much more vulnerable to fire than timber. Right? Have you ever seen a block of timber just catch fire when you strike a match, right? So you need some ignition temperature. And also, if it catches fire, then what wood does is it will form a layer of char, right? That black thing, and that char insulates the inner core of the timber. Right? So in the design, if you have taken care of that, so I'm going to provide some additional thickness to just let the char form. Your core skeleton is still intact. Right? So whereas that's not going to be possible with steel. It's still going to melt and just flow like a liquid. And same with the case with concrete. Right? Concrete's going to spall and crack and crush. So these are the information I have. Okay, durability again, right? So if you have, so the problem here is the moisture, right? So long as you have treated, seasoned your timber well, right, timber structures are as durable as concrete, and in some cases even better than concrete and steel structures. So this, the major problem with timber in our case is that you cannot really rely on the quality of timber, right? So we take a piece of steel and we know that any point on the steel has the same properties, but that's not possible with timber because that's why we call it anisotropic, right? Maybe stronger on the tail and weaker on the head. So that is the biggest challenge with us. So how can we rely on a member that has got a lot of variation in the quality, even in the same single specimen, right? And that's where the engineered wood products kick in, right? So there are ways to address this problem, right? So the biggest benefit of this engineered wood timber product are that we get the benefit of heavy timber without having to cut down any large trees. Right? So maybe we can discuss that in the Q&A session. So what is the scope in Bhutan then, right? So in the morning there was some discussion about whether it's 71% or 84%, but the official document I think is 71%, right? So, and then of the 71% coverage, we have 0.8 billion trees. So these are the forest proportion by tree, right? So by species. So 50% broadleaf, 20% coniferous. So what I've done is I've calculated the volume of timber that is in excess of the 60% mandated by the Constitution, right? So how much cubic meter of timber are there in the additional 11% of forest in our country? And that also from the seven species, seven most abundant species. So then what I did is I did a design for a 4-story structure, right? Having 8 units, so a typical building in a town, right? So that's quite common, a representative building. And as per my estimation, we need about 45,000 such buildings to provide shelter to the number of people that we are going to have in 2050. Right? So that's based on population growth and the average household size as per the NSB data. So I found out that we need additional 45,000 4-story buildings, okay, having 8 units. So then I calculated how much volume of concrete, how much volume of steel, and how much volume of timber would be needed to make those structures. So it turns out that we do in fact have more timber than what would be required to make those structures. If even we have to make it entirely out of timber, right? But that is on paper, right? All the timber are in the jungle right now, right? It's in the forest. So that's another challenge. But theoretically, it does seem that we would have enough timber just by touching the additional 11% that's in excess of the 60% mandated by the Constitution. So what does this say then? Right? So what does this tell us? So in the process, right, if we make all the structure out of timber, we would be sequestering. That means we would be capturing about 22 million metric ton of carbon dioxide. That is equivalent to taking off, how many million is that now? So 4 million, 73, yeah, so anyway, that many number of cars off the road for a year, right? Average passenger car is estimated to emit about 4.6 tons of carbon dioxide in a year. And if you can stop that many volume of carbon dioxide going in the air, it's equivalent to having taken off this many number of vehicles from the road for a year. Right? So that is the sustainability case for the timber. But as I told you, it's all on paper and theory. A lot of things needs to be done. So I just propose here 5. So we need to plant a seed now, right? So that we can reap the benefit in 2050. And we need to plant the seed now, and the seed needs manure, right? It needs fertilizers. And I propose 5 fertilizers. So the first one is sustainable forest management practices. We cannot have a thriving timber industry without a thriving forest, right? So we need to, as we say in Dzongkha, right, better to milk the red cow than kill it at once, right? So how can we do that? Right? So that's where the forest conservation people and ecologists should come in and start advocating and promoting sustainable forest management practices. Second one is revamping the forest industry, the timber industry. It's ridden with wastages right now, right? You buy 10 CFT of timber and you can only use 5 CFT in your building, right? It's full of wastages. And there's a lot we need to do in sourcing and in, maybe I'll run down quickly. Engineering standards, very important. The only document that I found so far was a document made by an Indian consultant in 1984, right? After that, there was no document on technical standards related to timber construction. We need manpower, of course, to know the technology. And then, of course, research and development in trying to see how we can further promote this. So finally, I'll skip all this. So under the leadership of our visionary monarchs, right, we have a very noble vision of having an ecologically balanced economic growth. So how can we achieve that, right? How do we honor our vision, right? So what will it take to fulfill this vision? Right? So it's time, I think we need to rethink the scale, the design, and the building blocks with which we make our infrastructure. So in that, I think we can draw some inspiration from 5 very critical stages in the life of Gautama the Buddha, right? Buddha was born under a tree. At the age of 5, he had his first taste of meditation under a tree. He obtained enlightenment under the tree. He preached his first sermon under a tree, and of course passed away under a tree, right? So would it not make sense for us as a Jainish people also to live in a building made out of tree, right? So, from all the reading and research that I've done so far, I have to admit I still do not know the name of this very wonderful tree we have in our campus. I asked all my colleagues, senior members, they also do not know, so maybe some of you here might be able to tell me what is the species or name of the tree here. And I would like to close by a proverb, a Chinese proverb. So it said that the best time to grow a tree was 50 years ago, and the next best time is today. So thank you.